Morning, everybody. It's Michael with Michelin Metals back again to talk about what? Nickel today. Today we're going to be talking about wrought nickel. Now, if you've been watching and you haven't subscribed, do me a favor. Click that little button right here. It says MMI. That's our subscribe button. It would help me out. I found out that about 8% of you that are watching that are subscribed. That's great. Thumbs up. 92% not subscribed. So, if you can, click that little subscribe button. Help me out. If not, one of those would be good. A little thumbs up. Thank you very much. Now, on to some nickel. So today's topic is focused on wrought nickel. Things commercially available are bars, forgings, tubing, plate, pipe, and all other, maybe some sheet. The commercially pure nickel 200 or generic alloy 200 has a UNS, which is the Unified Numbering System, chemistry designation of UNS N02200. It contains a minimum of 99% nickel plus cobalt, with other elements restricted. Carbon to a maximum of 0.15%, iron to 0.40%, copper to 0.25%, manganese and silicon to 0.35%, and sulfur to 0.01%. Of note here is that we said that there can be some cobalt included in the required minimum percentage of nickel because they are found together in the ores they are produced from. There is a higher cost in separating the two elements to greater degrees. Now, metallurgically similar in many ways, allowing nickel plus cobalt, when possible, is a matter of cost. Cobalt would be in the restricted elements if it were an issue in the performance of the alloy. The lower a cobalt content in a nickel alloy, the higher the cost of the raw materials to produce it. Nickel has excellent magnetic properties and high thermal and electrical conductivity. It is easily fabricated by any of the methods used for steels, and it is not hardenable by heat treatment. It has excellent corrosion resistance to atmospheric and marine environments, as well as caustic alkalis and reducing chemicals. Examples of applications are found in food handling equipment, chemical processing, and heating or cooling equipment in corrosive environments. Relatively high thermal and electrical conductivity are useful for electronic and aerospace applications. Nickel can be used in food handling equipment where heating and cooling take advantage of the ability to transfer heat much better than the 300 series stainless steels. Generally limited to applications below 600 degrees Fahrenheit. At higher temperatures, the low carbon content type 201 should be used to minimize graphitization. UNS N02200 has carbon reduced to 0.02 max from the 0.15 max of type 200 and extends the useful maximum temperature up to 1250 degrees Fahrenheit. Specifications for the nickel alloys are in the ASTM B series and the ASME SB series for boiler and pressure vessel code applications. As always, we say, check the spec. Always. Now, next up in the series of nickel alloys will be the nickel-copper alloys, the Monel 400, 405, and K500, or the Alloy 400, 405, and K500. Now, please make sure to stay tuned for those. If you're still here and you haven't subscribed, remember, click here. Come on, just do it. Click that little subscribe button. Not going to hurt you. If you've missed any of the previous videos and you want to check those out, right here. Check them out. Thanks for tuning in. We appreciate it. This is Michael with Michelin Metals.